Excuse me, Dr. Rossmith.
Yes, sir.
How you doing, sir? Before we started class, I just needed a quick question or clarification on vectors.
Sure.
So when you are asking for the components of something, that's just simply looking at the degree and also the degree and also what side, the measurement of the size. So for example, what is the component of A, and it'll be pretty much 50 at 60 degrees. So in my calculator, I will put 50 times the sine of 50 times the sine of 60 degrees, and then 50 times the cosine of 60 degrees, and that'll be it. While the magnitude, I will go a step further, and what I put the answers that I got from the sine and cosine and put that under a square root. I would square both, and then that'll be the magnitude of 50 at 60 degrees, hypothetically speaking.
Yeah. So firstly, of course, in terms of our lectures this semester, I haven't gotten to vectors yet, and I will. I certainly will. And I know there's a vector question on the homework, but we will do vectors before the homework's due. And so I'll get into it a lot more when we get to that point. But to answer your question specifically, that's exactly right. If you have something like a vector, as you say, 50, it's at an angle of 60 degrees, and I want the X and Y components, let's say, then yeah, you would say, okay, pretend it's like a little triangle here. The X side is the horizontal, the Y side is the vertical. And then you do your trigonometry. You'd say, well, if I want the X side, is that adjacent or is that opposite? That tells me, am I using cosine or am I using sine? And that would give you the X and Y components. Now, what you said for the magnitude is correct, that if I want the magnitude of a vector, I would take the square root of the X component squared plus the Y component squared. However, if you already know the vector is 50 meters at an angle of 60 degrees, well, the 50 is the magnitude. So if you already know what the vector is, then you know the magnitude. Now, if you were being asked what the magnitude is, it's probably because what you have is the X and Y components. And from there, you'd have to calculate what the magnitude is, which is exactly as you said, the Pythagorean theorem thing. But if you started with the vector to begin with, that means you were already given the magnitude and direction. And so just be careful about that. That way you don't do more work than is necessary. But yeah, exactly what you said. The only thing I would say to be careful about, to add to what you said, is depending on if the vector is pointing to the left or to the right or up or down, you also have to worry about positives and negatives as well. So in this particular example, because it's pointing up and to the right, the X and Y components are both positive. But if I had some other example that was maybe pointing like this, where this is 30 degrees, let's say, this is 50. Then when I tried to do this particular vector, the X piece of it, because he points to the left, would be negative, and the Y piece would be positive. But as I said, as we go through today, we're going to do trigonometry, which obviously is very related to this. And as soon as trigonometry is done, we'll start into the vectors and get a little bit more explicit. So yeah, what you said was exactly right. That's what is meant by give me the X and Y components of a vector. Start with a vector, make a right triangle out of it, and then get the horizontal side as the X side, and the vertical side is the Y side.
Thank you.
Sure. All right, so with that, I think we could go ahead and get started. So before I get into the material, unfortunately, I seem to be diagnosed with COVID myself, which is very interesting because I'm probably the biggest hermit you'll ever meet. I pretty much stick to my apartment. I do go to my parents' house for dinner on the weekends and stuff, but even me, who really doesn't meet with a whole bunch of people, not out partying and going to raves and stuff, believe me, uh, I did somehow catch COVID. So um, I think the worst of it is behind me. I'm still feeling, a good number of effects from it. But thankfully, this week we were supposed to continue online anyway to do the math review. So there's no worry about going into class with it or anything like that. But I don't know if this was the class I had told or one of my other classes, but uh, several years ago, about 20 years ago, actually, I was diagnosed with an immune disorder. And one of the things that has come up from that is I have to take immunosuppressants, which basically lowers my immune system to prevent the immune disorder from coming back and attacking my body again. It basically staves it off for as long as possible. Well, unfortunately, the side effect of that, of course, is that if I have a very low immune system, um, any illness I get is a lot more severe than is normally true. So even a cold is pretty hazardous to me. So as it pertains to the COVID thing, I'm being treated and all of that stuff, but how long it's going to last and how long I have to quarantine is longer than is normal. I think the CDC recently came out and said if you have the Omicron variant, you have to quarantine for 5 days, I think it is, rather than what was originally 2 weeks. But because of my particular condition, I'm not sure 5 days is not enough. Because it's been 3 and I'm not even close to being done. I'm not feeling better yet. So I say this first of all, in case something happens where we have to miss a class, I'll email you about it, but it would be because I can't talk or something like that, just because of the coughing and all of that stuff. Today, I'm fine enough to be able to do this. I don't see anything popping up. I'm going to try not to be too annoyed by the headaches and stuff, and I'll be able to answer questions sufficiently. But just know that if for some reason I have to be at a doctor or I just am not well enough to be able to give a lecture a particular day, that's why. That's what's going on. But again, if something changes in our standard stuff, I'm going to send an email and let you know. That way you're not hanging around waiting, why in the world am I not in the Zoom meeting kind of thing. Also, I did the online poll thing. I'm going through all the results and all of that. And when I find out how we're going to handle online lectures from here on out after this week with the math review stuff, I'll be sure to let you all know. So be on the lookout for that. But the only other formality is Canvas has all the last year's lectures posted for each of the different math topics. If you didn't see them, they're there for you to be able to look at if you want to kind of go ahead of where we've been, or you just want to hear maybe slightly differently how I taught it then versus how I'm saying it now. Same material, nothing new, but it's just what I did a year ago. Also, practice problems are there with the solutions. So if you're working, let's say, if you're trying to study it, review the math stuff, you could look there and see how I worked particular problems if you're getting stuck on anything. And then the big one, of course, is that the homework assignment was posted, I think either Sunday or yesterday, I forget, or Monday, I should say. but it's due Sunday, this coming Sunday by midnight, 11:59 p.m. I always hated it when a teacher would say it's due Saturday at midnight, because I never knew, did they mean Friday going into Saturday that midnight, or is it Saturday and then midnight hits and it's now Sunday? That's why I make things 11:59 p.m. so there's clarity about what day I mean. So Sunday evening, 11:59 p.m. the homework's due. Basically, if you didn't have me last semester and you don't know how the homework works, you go to Canvas. I set up the class in modules, so each topic is its own module, and I try to format the modules so like there's a little section for the videos, a little section for practice problems, and a little section for homeworks. The homework assignment is there, you click it, and it basically, it's a PDF file. You download it and it's got, I think this one has 3 or 4 questions. You can either print it out and write, solve the solutions on the paper, and then either, if you have a scanner, you could scan it back into your computer. If you don't have a scanner, then you could use your phone, take a picture, and be careful to make it nice and clear so I'd be able to read it. Or if you have a way of writing, with your iPad or something like that, you could do it that way. Or a separate sheet of paper. If you don't want to have to print it out, you get a blank sheet of paper. As long as, of course, you're showing all your work, so I see what you're doing, and you box your answers. Anyway, once it's done, you have it all worked out. As I said, you somehow get it back onto your computer, whether it's by taking a picture with the camera or scanning it in, and you submit it back from that same Canvas homework assignment page. There's a button that says submission. You submit it, and that's that. From there, I'm able to see what's submitted, what's not. I can grade it. I can physically grade it on the thing you submit, and that way, when it is graded, you could go back and look what did I mark and all of that stuff. So, of course, if you had me last semester, then you're comfortable. You know how the homework and test submission stuff goes with that. So that homework assignment is posted. It's got a little bit of all the math review stuff, a couple of algebra problems, a trig problem, and a vector problem, I think, is how I did it. Just a little bit of everything just to make sure you're going through it. And like I said a little earlier, I obviously haven't done trig and vectors yet. So if you're not comfortable doing those yet, that's perfectly fine. We haven't gone through it this semester, but that's what we're going to be doing today and Friday. And so by Friday, you should have it all down and be able to go ahead and work all the problems on the homework. But if you want to submit it early, you're more than welcome to submit it early too, just to get it out of your hair. All right. So I think that is, I think that's all the formality. So with that, let's go ahead and get to the actual work. So last time we did the algebra stuff, we went over basically the types of algebra you may see in the class. So today I want to go through trig, because trig is what gives us vectors. And as I said with algebra, the same definitely holds true with trigonometry. There's a lot to the topic of trigonometry when you're in math class, and the vast majority of it we're not going to worry about. There's only a certain part of trig that we're going to be using. Everything else, just don't worry, you could disregard it for our purposes. So things like the law of sines and the law of cosines, double angle formula, half angle formula, all those fancy tricks we're not going to need. What we need are the basics of right angle triangle relationships. And that goes like this. Say you have a right triangle, which is a triangle that has a 90-degree angle in it somewhere. So in this case, there's your 90-degree angle. When you have that, then you have 3 sides. It's a triangle, obviously. So let's say, call this side A, this side B, and this side C. That's generally what's done. And it turns out that there's a special relationship for a right triangle. There's actually many special relationships. The first biggest one, the most famous, of course, is what's called the Pythagorean Theorem. Pythagorean Theorem. And what it says is that if you happen to know the length of the two smaller sides of a triangle, which in this case would be side A and side B, then you could calculate the missing side, the longest side, side C, from a certain formula. And it goes like this. A squared plus B squared equals C squared. Very nice formula to remember. I think everybody's heard of it. Everybody remembers it. Even if you don't think about it, just the sound of A squared plus B squared equals C squared. You just remember that. And it turns out this holds for right triangles. If you have a different type of triangle that doesn't have a 90-degree angle in it, then there's something more fancy that fixes the Pythagorean theorem to work with those other triangles. But for the special case where it's a right triangle, this is the nice, easy version. And that's what we're going to have in physics, the nice right triangles. Now, how do you know which side is A, which side is B, and which side is C? It doesn't matter which is A and B. You could call A B or you could call B A. It doesn't matter. The important one is which is side C. That's the one you have to know that's separate from the other two. And it's actually really easy. It turns out that the size, the length of a side of a triangle is related to the angle across from it. So if you look, for instance, this angle right here tells you something about how big that side will be. And if you imagine growing the angle, making the angle more and more open, that's going to lift this higher and higher. And so side B is going to get longer and longer. So there's some relationship between the angle, one of the angles, and the side that's across from that angle. And so you will always know which is the biggest side because it's the side that's across from the biggest angle. And it turns out that a right triangle, the biggest angle you could possibly have is the 90-degree angle. So inevitably, when you have a right triangle, if you see where the 90-degree angle is, the side that's across from it is always C. And we call C the hypotenuse. Hypotenuse. Now, this is what I don't know how to spell. Maybe EU, I'm not sure. But we know how to say it, hypotenuse. The other two, A and B, it doesn't matter what you call them. They're just names. They're just labels. They're the other two sides. C, the hypotenuse, that's the important one. And it's always the side across from the right angle. So that's our first big relationship. The Pythagorean theorem always holds for a right triangle. And now in general, when we go to actually do something, let's say we want to calculate what is C, we usually write it C equals the square root of A squared plus B squared. You know, when you actually go to calculate, this is what you do, because you don't want C squared, you want C. All right. Now there's another set of relationships that's important here. And this set is kind of known by this name, Sohcahtoa. Okay, most people, at least here in the United States, learn Sohcahtoa when they talk about trigonometry, but I've learned that other nations don't teach Sohcahtoa because they don't speak English. So they may teach it in a different way. This is how I learned it, so this is how I'm going to teach it to you. Sohcahtoa stands for three relationships. Each one is broken down into three letters. So you have SOH, then CAH, and then TOA. So the first one, so that stands for the sine of an angle, theta. So if you pick one of the angles in your triangle, the sine of that angle, sine being a trig function, tells you, or is the same number, is the same value as the opposite side of that angle. So for instance, if this is our theta, then the side opposite to theta is this B. It's on the other side. So the sine of an angle theta is the opposite side divided by the hypotenuse. Okay, and that's what SOH stands for. S is sine, O is opposite, H is hypotenuse. So the SOH stands for this little equation. So this equation allows you to calculate stuff. It depends what you have and what you're looking for. If you're looking for the angle, then there's your equation. However, sometimes you may have the angle and you're looking for, what is side B? Well, then I'm searching for the opposite side. I'm searching for the O. That'll be my variable that I search for. CAH, very similarly, CAH stands for cosine of the angle is the same value as the side adjacent. Now, adjacent just means next to, okay? Next to instead of across from. So in our thing, A is next to the angle theta. So that's the adjacent side divided by the hypotenuse. So again, CAH, cosine adjacent hypotenuse. And in the last one, the TOA, that says the last trig function, tangent of the angle theta, is, of course, opposite O divided by adjacent A. Okay. So those are the big three relationships. Well, the big four. You've got Pythagorean theorem, and then these three trig relationships, sine, cosine, and tangent. And with these four relationships, you can do anything you want with a triangle. If I give you a triangle with some missing information, you could use these relationships to calculate that information. So let's try an example. So let's say I have the triangle. Let's say this is 4, this is 3. Here's theta, here's phi. And of course, this is a 90-degree angle. And I'd like to know, I'll call that R. I'd like to find the value of R, theta, and phi. Theta and phi, they're just Greek letters. They're variables, they're names. For some reason in math, when we talk about angles, they like to give the angle names Greek letters instead of Latin letters for whatever reason. So theta, that's the usual generic default variable. And when theta is used, phi or phi, P-H-I, is the next one that they use. And then sometimes tau and other ones. But they're just it's just a letter. So there we go. There's my problem. Given this triangle, I have some pieces of information and I need to calculate the other ones. It's like a puzzle. Can I figure out what I need from the given information? Well, I have 4 relationships to use here. First one, I look at this triangle and I say, okay, well, I know 2 of the sides. Anytime I know 2 of the 3 sides, I can always get the third by the Pythagorean theorem. So let's do it. This is to calculate R. I want R here. R happens to be the hypotenuse. How do I know it's the hypotenuse? Because R is the side opposite to the biggest angle, which is the right angle, the 90-degree angle. All right, so I want the hypotenuse. What do I know? I know the 2 other sides. Pythagorean theorem says a squared plus b squared equals c squared. So 3 squared plus 4 squared equals r squared. Okay. And now it's just an algebraic problem. How do I calculate? Simplify it. 3 squared is 9 plus 4 squared is 16 is r squared. 9 plus 16 is 25 is equal to r squared. But I don't want r squared. I want r. So get rid of the square by taking the square root. Thus, r must be plus or minus 5. Now, I know it's not minus 5 because it's the length of a side, and the length is always positive here. So I could just get rid of this stupid plus or minus, and it's just 5. So I now know the hypotenuse is 5. Now, some of you may have known it was 5 from the very beginning because there's a little special relationship. There are certain lengths that go together very neatly, and this happens to be one. It's called a 3, 4, 5 triangle. If you have a right triangle where the two smaller sides, one of them is 3 and one of them is 4, then the hypotenuse is automatically 5. And multiples. So if you have 6 and 8, well, 6 is 2 times 3, 8 is 2 times 4. So the hypotenuse must be 2 times 5, which is 10. Now that's just a little fancy technique. If you don't know the fancy triangles, don't worry about them. Pythagorean theorem gives us the answer. So I now have one of my answers. R is done. What about the angles? How do I do that? Let's pick one. Let's do theta first. All right, theta is what I want. Well, in order to calculate the angle, the relationships I know that have angles in it is Sohcahtoa. Okay, so I have to choose one of the 3, sine, cosine, or tangent here, to use to calculate theta. Which do I use? It depends what I know. If I want to use sine, then I need the opposite side and I need the hypotenuse. If I want to use cosine, I need the adjacent side and the hypotenuse. If I want to use tangent, opposite and adjacent. Now here I know all 3. I know the 3, I know the 4, and I just calculated the hypotenuse, the 5. So now I know all 3 sides. So it doesn't matter which I use. But there's a little thing I will give you a tip about in general. That is a fairly good tip to remember. And that is, if you're working in a real problem, so someone gives you something to do, a project to work on, and you have to calculate data. You can make mistakes. We all can make mistakes. And so it's possible that when I went and calculated using the Pythagorean theorem and I got 5 as the answer for R, maybe I plugged something in my calculator wrong. So 5 is not the right answer. Maybe it's supposed to be 6, but I don't know it. I think it's 5. Well, if I use 5, which is wrong, to try to get theta, let's say I use sine is opposite over hypotenuse, and I use the wrong value for the hypotenuse, then obviously theta is going to be wrong. However, if instead I use the data that was given to me that I know is right, so for instance, the 3 and the 4, those I didn't calculate, so they can't be a mistake. Then when I go to calculate it, as long as I calculate it correctly, I know it's going to be right. I have no issue. I'm not worried about, well, I'm using something I calculated before. Maybe I did that thing wrong. And if I did that thing wrong, then this is going to be wrong. And everything down the line is going to be wrong. So a good thing to get used to is if you have the ability to only use the information that was given in the problem and not information you yourself how to calculate. You don't have to. If you're confident in this answer, then you could use it. That's perfectly fine. I'm just saying to be the safest you can be, because when you go to real work in your career, if you're an engineer, you're a doctor, whatever you're going to be, if you're working in a lab, and they say, hey, do all the calculations for these different concentrations and stuff like this. And you made a mistake, and then all the other data is wrong because of your mistake, you could be fired. However, if you do your calculations using the data they gave you, well, either it's right, which you're good, or it's wrong, and it's wrong because they gave you bad information, which is not your fault. So you're safe. So with all of that said, when I look at this problem, I say, I'm looking for the theta. I know the 3 and I know the 4. Those were given. Can I use one of the trig functions that only uses those 2 sides? And indeed I can. The 3 is the side opposite to theta, and the 4 is the side adjacent. So looking at Sohcahtoa, the Toa part here uses the opposite and the adjacent sides. So that's what I'm going to do. Tangent of theta is the opposite side, which is 3, over the adjacent, which is 4. Perfect. Now all I have to do is calculate theta. The problem is, what the heck? I don't want tangent of theta. If I calculate 3 over 4.75, that's not the answer. That's tangent of theta. What I want is theta. So how do I get rid of this tangent? Well, it turns out that to get rid of the tangent, it's the same as this other thing. So just quickly as an aside, if we have the question 5x equals 10, I'll say, okay, that's fine, but I don't want 5x. What I want is x. So how do I calculate x? I do the opposite of whatever operation's happening here. Here, I'm multiplying the x by 5. To get out of that, I do the opposite of multiplying by 5, which means divide by 5. Okay, and whatever you do on the left, you got to do on the right. So by dividing by 5, you've done the opposite operation, which cancels out that 5. And now you're left with x is equal to 2. So we know how to do that from algebra. Well, it turns out the same thing happens here. I have tangent of theta equals something, but I don't want tangent of theta. So to get rid of the tangent, I do the opposite of taking a tangent. Well, what the heck is that? It turns out it's something called the inverse tangent or arctangent. So it looks like this. It looks like tangent, but it's got a little -1 as a superscript. So when you do that to the tangent of theta, what happens is this thing cancels that thing. So instead of taking the tangent, you've taken the inverse tangent of the tangent, they cancel out. However, be careful, because whatever you did on the left, you got to do to the right as well. So we have an inverse tangent over here now on 3 over 4. But this is good because now we've got theta, which is the thing I want, is whatever this happens to be. Now, unless you're a big math genius, we're going to be sticking this in my calculator and we get an answer for it. Now, be very careful. I actually don't have my calculator with me. It doesn't matter what the number is for now. The process is what's important. But if you're doing this and you want the answer right now, firstly, make sure your calculator is in degree mode, not radian mode. And then what you're going to find on your calculator is wherever you have the trig function, sine, cosine, tangent, above them, usually you have to push the second function key. Second sine or second tangent gives you the inverse tangent. So it's not tangent of 3 over 4, it's the inverse tangent of 3 over 4. Some older calculators write it like this, arctan. They mean the same thing. So if you ever see arctangent means inverse tangent. It's the same thing. But there you go. Take the inverse tangent of 3 over 4. I think it turns out something like 36 maybe. I forget what the actual answer is, but something like that. But that's how you get it. So here, I used the 3 over 4. I could have used the 5. If I wanted to use the 5, I would have done a sine or a cosine instead. But because I wanted to be safe and not use something I calculated before, I used the 3 and a 4. That told me I have to use tangent because it's the opposite and the adjacent sides. And then I just use algebra and calculate theta. Any questions on that, by the way?
I have a question.
Mm-hmm.
So, when should I put my calculator in radians, and when should I put my calculator in degrees?
Yeah, that's a good
solving
question.
these problems.
Okay. The rule will be this. In physics, always degrees, never radians. if you want radians, then likely you're in a math class. Now, that's for our purposes. Me, when I'm doing problems in advanced physics, we go back to radians. But for our purposes in general physics or college physics, all the angles we're given here are always going to be degrees. You're never going to be in radian mode in my class.
So just
So,
keep it in degrees, though. Just keep it in
yeah,
degrees.
just keep it in degrees. And I say that because a lot of times people are taking math and physics at the same time. And so you go to math class, you got to change it back to radians, and then you come here, you forget that you're in radians, especially on a test. But if you're not taking math, then never put it in radians. But definitely in physics, degree mode is always going to be true for us. Any other questions? All right, the last, we still got one more to go. We got 2 out of our 3. We still need phi. Now, phi is nice because we have an option here. There's 2 ways of going about calculating phi. Well, there's actually a lot of ways. There's 4 ways of calculating phi. But either we do it just like we did theta. We say, okay, I want phi. Phi is up there. Again, I don't want to use the R here. So I'll say tangent of phi is the opposite side, which in this case is the 4, over the adjacent side, which is 3. So phi then must be inverse tangent of 4 over 3. And you get 52 or some such thing. That's one way of doing it. So if you do it for theta, you can do it for phi as well. There's a second way of doing this, though, and that is one more relationship I didn't say, but this relationship is true of all triangles, not just right triangles. This relationship says that if you add up all 3 angles in a triangle, you will always get 180 degrees. So if I wanted to use this relationship, I'd say, okay, if I want phi, what do I know? Well, I know theta plus phi plus the 90-degree angle. Those are my 3 angles in my triangle, all add up to 180. Okay. So bring the 90 over to the other side. Theta plus phi is 90. And let's say theta, I'm not sure it's the real number. Let's just say it's 36. So this is 36 plus phi is 90. So phi is 90 minus 36, which is your 54, 53, whatever it's going to be. Okay, same answer. So it depends what you like. You could use the trig functions, calculate phi, or you could use the fact that you know 2 out of the 3 angles, so the third one's easy. It's 180 if you add 3 up. And that's trigonometry. That's everything you need to know about trigonometry for this class. Given a right triangle, you'll know some stuff, you won't know other stuff. How do I calculate the stuff I don't know? There are certain relationships. First primary one, Pythagorean Theorem. And that just relates to 3 sides. The sum of the squares of the 2 smaller sides of a triangle is the square of the largest side. By the way, if you've ever seen The Wizard of Oz, when the scarecrow gets his brain and he's smart and he shows that now all of a sudden he's smart and he can think, he says the Pythagorean theorem to prove it. He says it just like I did. The sum of the square of the 2 smaller sides of a right triangle is equal to the square of the larger. So that's just a funny thing in a movie. It sounds way smarter than it really is. We all know the Pythagorean theorem, but when he says it like that, it's like, oh my God, he must be a genius. So Pythagorean theorem, done. Sohcahtoa, 3 different relationships, and which one you use depends on what you know. It's always an angle and 2 sides. So do you know the sides that are opposite? Do you know the side that's adjacent, or do you know the side that's the hypotenuse of the triangle? And depending on which two you know, that'll say, am I talking about sine, cosine, or tangent? So if you think Sohcahtoa, you'll always remember sine is opposite over hypotenuse and cosine is the adjacent. Just because you say Sohcahtoa, it tells you. All right, now let's try one more example. Let's do this. Okay, let's say this is 10, 6, and theta. Oops, that's phi, so this will be theta, sorry. All right, and let's call this y. So there's a triangle. A right triangle, because there's a 90-degree in it. And I know some sides, and I'm looking for the third side and two of the angles. Okay. How do I do this? Let's look at the side first. Usually when there's something and you know two of the three, that's the one you want to do first because it's the easiest. So because I'm talking about three sides, this is Pythagorean theorem. And that says a squared plus b squared equals c squared. Now, which sides do I know? Well, I'm looking for y. Is y the hypotenuse here? Can anybody tell me, is y the hypotenuse here?
No, 10 is the
Right.
hypotenuse.
How do you know that?
10 is the hypotenuse because of the right angle that's across from it.
Perfect.
And
Yes. That's exactly right. But the right angle's right there. And the 10 is the side opposite of it. So the 10 is the hypotenuse. So that's our C. So that means this Y is just one of the other two sides. Is it the A? Is it the B? That doesn't matter. All right. Well, that's good to know. And this is something important to know, especially when you're a beginner with this stuff, is just because there's one side you're looking for, that's not always the C. Sometimes it's the A. So just be careful. So for our Pythagorean theorem, we know 6 squared plus y squared is equal to 10 squared. So the C we know is 10. A and B, well, the 6 could either be called A or it could be called B, but it doesn't matter which one is which because they're just added together. So I called the 6 the A and B is, I'm calling it Y. So I want to solve for Y. That's no big deal. 6 squared goes to the other side. Y squared equals 10 squared is 100. 6 squared is 36. When I bring the 36 to the right side, it becomes negative. So it's there's no square here, sorry. It becomes 36. And 100 minus 36 is 54. So we have y squared equals 54. But I don't want y squared. Not 54, 64. You see, my brain is off because of how I'm feeling. I apologize. 64. I don't want y squared. I want y. How do I get rid of the square? Square root both sides. So y must be 8. So I now know how big y is. Y is 8. Good. Now we have two angles to worry about, theta and phi. Let's look at theta. This time I'm going to break my rule. No, I don't have to. I don't have to. Good. I want to use the data given in the problem. I don't want to use what I just calculated. So what do I know? If here's theta, I know the 6, and the 6 is adjacent. It's the side next to the angle. And I know the 10, which of course is a hypotenuse. We just figured that out. So I know adjacent and I know hypotenuse. So when I say Sohcahtoa, adjacent and hypotenuse goes with cosine. So I have cosine of theta is the side adjacent, which is 6, over the hypotenuse, which is 10. All right, now what do I want? I want to get rid of this cosine and just stay with theta. So I do the inverse cosine of both sides, and that leaves me with theta on the left. But because I did inverse cosine, there he is sitting there on the right, acting on 6/10. And so I would plug this in my calculator. And again, I would get some value. Now, what about phi? Same thing with phi. I could do the 180-degree trick, or I could do the trig functions. Let's do trig, just to practice them. So for phi, what do we know? Let's look at phi. So here's phi. The 6 is the side opposite to that angle, and the 10 is the hypotenuse. So now I need opposite and hypotenuse. So that tells me sine. So I'm going to say sine of my phi is the 6/10. And just like before, I don't want sine, so get rid of it. So I have to do inverse sine on both sides, cancels the sine. So I'm left with phi over here. And the inverse sine is now over here, the 6/10. Plug that in, and again, I get a nice answer. And so this is trig. This is everything we need to worry about with trigonometry. There's going to be stuff I know. Use that stuff to get the stuff you don't know. How do I use it? There are certain relationships, Pythagorean Theorem and Sohcahtoa. With those relationships, any right triangle, given the right information, I can calculate. Now, why do I need to know this? Because in physics, we're not working with triangles. This isn't a math class. Well, this is going to be important because what is in physics is what's called vectors. Now, everybody's done physics 1. And so hopefully, I think if you had me, you remember we talked about physics or vectors a lot. And if you had someone else, I hope they talked about vectors as well. But it turns out that in order to work with vectors, there's a certain type of mathematics you have to do. You're not just adding numbers or multiplying numbers. When you have vectors, there's certain rules you have to follow. The good news is the rules imitate trigonometry. And so just to see a little hint, which is what we're going to do on Friday, but just a little hint or a preview, it'll look something like this. Say we have a coordinate system. Someone starts here. They're at a camp. They start at their tent, and I'm told they walk 10 meters away at an angle of 30 degrees north of east. So that would look like this. They would walk this way. And I'm told that how far do they walk? 10 meters. That means the arrow I draw relates to 10 meters long. And I'm told that the angle that they make is 30 degrees north of east. So of course, here's east, here's north, west, and south, or X and Y directions, basically. And something I can ask is, given that they walk like this, if they wanted to walk like that in a different way, so someone wants to retrace the steps and get there. Let's say someone wants to walk straight to the right, straight east, and then they want to walk straight north, and they want to meet up with that person. Okay, so maybe there are paths in the woods at this campsite, and the paths lie due east and due north. But the person went through the woods at a diagonal as a shortcut. So they want to meet up. So the question is, this green guy, how far should that person walk in the X direction or the east direction, and then in the north direction to get to the same place? Well, all that's asking in a very formal way is asking, find the X component and the Y component of this vector. Let's call the vector A. So I want the X component of A and I want the Y component of A, where the X component means how far to the east and the y component is how far north. Now, I just gave you the biggest clue you could possibly see about how to do this. Take your vector, you make a little right triangle out of him by having a horizontal side and a vertical side. And then all you're looking for, there's the x, there's the y. You have a right triangle problem. Calculate these two sides. Given you know the hypotenuse and you know an angle. How would you do it? We go back to trig and we say, we have Sohcahtoa. That's one relationship set we can use. And we have the Pythagorean theorem. And it's our job to use those two tools to get this problem and solve for what it is we're looking for. And it turns out this is important in physics because these are the things we could use in our equations. We can't use this full 10. The fact that the person walked 10 meters in this weird direction, I can't use it in my equations. What I can use is how much of that 10 is in the x direction and how much is in the y direction. So I have to be able to get these pieces of information to do all my equations with. And we're going to get into that. Now, this, as I said at the very beginning of the semester, this particular semester is not heavy in vectors. But I want to go over them again because we're going to see them some. But this isn't going to be the biggest thing in this class like last semester was. So Friday, we're going to do a bunch of examples on vectors themselves, but just know vectors is nothing more than the trig we just did today, but it's seen slightly differently. You put different wordings and different names on things. All right, so we are done for the day. You're free to go. If you have any questions, you're welcome to ask. But be sure to visit Canvas. Make sure you're taking advantage of any resources there that you need. And of course, if you're having problems with the homework, you want to email me or something, that's fine too. But Friday, vectors. And once that's done, we should be done with the math review stuff. All right. So other than that, you're free to go.
Have a nice day.
Take care.
Have a good day.
Bye.